A sound source that is 4.5 meters from us is hitting us with 3.4, and that's milliwatts per square meter. So our X is 4.50 meters, and our power, or our intensity, our intensity is 3.4 times 10 to the minus third watts per square meter. Okay. What is the intensity if we are 6.7 meters from it? All right, now, if we're farther from it, it's going to be fainter, right? So we're going to reject any calculation here that gives us more intensity than 3.4 milliwatts, right, per square meter. All right, so again, we're going to set this thing up this way, right? I is equal to some constant over x squared, right? Okay, that's what that formula says, right? All right, so our first one, 3.4 whatever, right, is equal to some constant over 4.5 squared. And they're asking for the intensity. So the unknown intensity is the same constant divided by 6.7 squared. So if I divide the sides by the sides, I get 3.4 over I equals, and then by the time you sort this all out, you'll end up, the k's will cancel, which is why you can actually solve this, and then 6.7 squared on the top and 4.5 squared on the bottom because of the 1 over the 1 over thing, right? Okay, so I'm going to go this times this divided by this. 3.4 milliwatts per square meter, right, times 4.5 squared divided by 6.7 squared. And I get 1.53. And that would be milliwatts per square meter. It's kind of confusing, right? Is that M that looks like a meter, right? A milliwatt and a meter. So we have to be careful with that. I suppose it's not a good idea to write that way. All right, now back of the envelope, just total back of the envelope for this, right? Take your 3.4. We're going to multiply it by the ratio of the distances squared, okay? Now we know it's got to get smaller because we're farther from it, right? So therefore we put the 4.5 on the top and the 6.7 on the bottom. So 3.4 times parentheses 4.5 divided by 6.7 end parentheses squared. Boom, same exact answer. Okay? All right.